Hello class, this is Mrs. Sauer with our very first video. So bear with me, it's a first timer for me too. Alright, so since I am not there with you, I would like to go ahead and make this video so that you get the notes and you get the explanation from my own voice of how to solve these types of problems. So today we are going to use trigonometry to find the missing angles on right triangles. Last class we found the missing sides using trigonometry. This time we're using the trig to find missing angles. So first things first, do the warm-up that's on the front of that was at the front table like you always do. I went ahead and put the answers to the warm-up on the back board, so go ahead and check your answers. Make sure you got the same thing I've gotten. That was what we did in the last class, was finding those missing sides using our trig, our SOHCAHTOA. And I put SOHCAHTOA at the front of the board also, so you have all your formulas there. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. You will go ahead and hold on to your homework that was due today and hold it until I see you at the next class. So, and along with the same assignments that I'll give you on Monday here, and then Wednesday with your review packet. I want you to hold everything until I see you on our class day on Friday. And that will be our test day. So I'll answer any questions you guys have, collect all your work that you've been holding on to, and then we'll go ahead and take our test. So today, pardon me, we are going to be doing trig to find missing angles. So let's go ahead and first cover since I told you the warm-up's on the back board, we're going to skip it on this video. For our objective today, we're finding missing angles using trig. And let's get started. I have given the sub the packet for your notes and along with the warm-up. In fact, never mind, the warm-up is in with the packet. So he's going to pass that out to you guys. All right, so number one, we're trying to find our missing angles. We have two missing angles on there. We already know the angle C is the 90-degree angle. So let's go ahead and circle A, because that's the first one we're going to find. On this left side, we're going to be setting up our problem to solve for angle A. On the right side, we're going to set it up to solve for B. So on the left, it says, what is your reference angle? Well, A is going to be our reference angle for this side, because that's the one we're trying to find. So if A is my reference angle, I need to go ahead and label what my opposite, adjacent, and hypotenuse are. So this side is my opposite side from angle A. My hypotenuse is always across from my right angle. Sorry about the handwriting, it's going to be a little funky today with this tablet. And then the last one is my adjacent side. All right, so now that we know our sides in reference to angle A, our reference angle is A, what sides are we given? So they told us that this side, the one with the CB side, we have 7. That's also our opposite side. So we know our opposite side. You put OPP for opposite. You put O, you put whatever you want. And we know that side is 7. And then our adjacent side here is that AC side, and that is 4. So we know the adjacent side and the opposite side. So if you look at your SOHCAHTOA, I'm going to go ahead and write it SOHCAHTOA up here so we can see it on here. So we know our formulas. Like I said, I do this every time I do trig. I write SOHCAHTOA at the top of my paper. So I don't have to think about those formulas. They're all right there for me. The less I have to use my brain, the better. All right, so we know the sides that we're given, the 7 and the 4, are opposite and adjacent. So since we're working with opposite and adjacent sides, that means we're going to be using tangent, because tangent is opposite over adjacent. So that's the trig function we're going to use. Now before we set up B, I want to go ahead and solve for A. I like to finish up with A before we move on to B, angle B. So since we're using tangent, we need to set up our correct trig function and our ratio for that. Ratio just means fraction. So I'm going to use tangent of A, because that's the angle we're trying to find, is equal to, now remember it's opposite over adjacent. Bear with me, this tablet's a little funky. All right, so opposite over adjacent means we're doing 7 over 4. All right, so this is my formula. This is what I have to do to set it up. Now, what we're trying to find is angle A. So I need to get this A by itself. To do that, I got to get rid of this tangent. So I got to do what's the opposite of tangent. So just like, let me write up here. If I had a problem like x plus 2 equals 5, and I needed to get x by itself, I would subtract 2 from both sides, right? Because that's the opposite of adding. Here, we got to do the opposite of tangent. Well, the opposite of tangent is called tangent inverse. And the way we write it is tangent with, it looks like a -1 exponent. Now, it's not really an exponent, that's just how we write tangent inverse. So I'm going to take the tangent inverse of both sides, because whatever I do to one side, I got to do to the other. So tangent inverse of tangent A is equal to tangent inverse of 7/4. Sorry, that's a 4. All right, so how we do that, the tangent inverse of tangent, they cancel each other out. So all I'm left with is A on that side. And then on the other side, I have tangent inverse of 7/4. And if these notes are ever hard to read, I also have uploaded our notes for this onto Edline already. So if anything of here is hard to read, pull up those other notes and make sure that you have written what I have written. It's just a little hard to write on this tablet. So what we have to do is, now that we have A by itself, I need to type into a calculator tangent inverse of 7/4. So the way I do that, here's a picture of a calculator. You know how we have our sine, cosine, and tangent buttons here? Well, if you look on those calculators in our classroom, above that sine, cosine, and tangent buttons, it'll say sine inverse, cosine inverse, and tangent inverse in blue letters on these calculators in our classroom. The reason it's written in blue is it means up here we have the second button, but in our class it's blue on our calculators. So we're going to hit that blue button and then hit tangent button. So we'll hit the blue button, the second button, and then tangent button, and that'll pull up tangent inverse on our calculator. So once you do that, in your calculator, you're going to hit the second button and then the tangent button, and then type in 7 divided by 4, and you'll get our answer, which angle A is equal to 60.2 degrees. I went ahead, since it gives me a decimal, I just went ahead and rounded to the nearest tenth. And since we're talking angle, we put a little degree symbol there, a little circle. So our angle A is 60.2 degrees. And we're done. That's how we find angle A. So basically, you just got to set up this tangent function and then get A by itself by doing the opposite of tangent. Opposite of tangent is tangent inverse. Whatever you do to one side, you got to do to the other. So the tangent inverse cancels out the tangent. We're left with A. A equals the tangent inverse of 7/4. Type in your calculator, and you're good to go. You got your answer. So let's go do the same thing for angle B. Okay, I'm going to use a different color for angle B. I know you guys are writing notes with pencil, so if you don't have colored pencils or anything like that, or highlighters, to use a different color, what I recommend is draw another one of these triangles right here and relabel it so that you can circle your reference angle of B. But for me, I'm just going to use a different color. So this time, since I'm trying to find angle B, I'm going to circle angle B here. Now, since angle B is my reference angle, I got to figure out what's my opposite, my adjacent, and hypotenuse based on that angle. So coming over here, this is my opposite side. Down here is my adjacent side, and hypotenuse is always the same. It's always across from your 90-degree angle. All right, so now that I've got my reference angle, I know where everything's at now, and we're finding angle B this time. My reference angle is B. What sides are we given? Well, this time I'm given the opposite, and this time my opposite side is 4, and I'm also given my adjacent, and this time my adjacent is 7. Because it's the reason they got flipped like they did from angle A is because my reference angle got switched. So from angle B, my opposite side is 4, my adjacent side is 7, and my hypotenuse is the same. All right, so which trig function are we using? Well, we've got opposite and adjacent. So again, opposite and adjacent is tangent function. So we're going to use tangent again. So let's go ahead and scroll down here and set up our function. So tangent of B, because this time we're finding angle B, is equal to our opposite over our adjacent side. So opposite was 4, adjacent was 7. So it's going to be 4 over 7. Sorry about the handwriting. All right. So now that we've got it set up, now we got to solve it. We got to get that B by itself. So again, the opposite of tangent is tangent inverse. And when we work with sine and cosine, the opposite of sine is sine inverse. The opposite of cosine is cosine inverse. So tangent inverse of tangent B, sorry, my pen, is equal to tangent inverse of 4/7. Because whatever we do to one side, we got to do to the other. All right, so now my sine or my tangent inverse cancels out my tangent. So I've got B equals tangent inverse of 4/7. And this is where we plug it into a calculator. Now, if you do not have this type of a calculator at home, there is, on our phones, there is no tangent inverse, sine inverse, or cosine inverse. All they have is sine, cosine, and tangent. So what I recommend is at home, set up your problem and do all the work up to the point where you have to use your calculator. Then just leave it the way it is, bring it into class the next day, or the next time we have class, and then go ahead and take the first few minutes and go ahead and plug in all your problems, get your answers on our calculator, and that way your homework's done. So I'll give you a few minutes on that next class to go ahead and take care of that. All right, so plugging in tangent inverse of 4/7, I get 29.7. Sorry, I rounded wrong. Let me double check myself. Tangent inverse of 4 divided by 7, 29.7. So let me check and see if I rounded wrong on the other one. So tangent inverse of 7/4 for A. Oh, I did wrong, rounded wrong. On this one, it should be 60.3 when you round, because it was 60.25. So that gives me 60.3, and then B equals 29.7. Now the nice thing, the reason I was able to catch myself is if you remember, all on your triangles, all three angles always add up to be 180 degrees. Sorry. So when I add the two angles that I got plus the 90-degree angle that was already there, it should equal exactly 180. So I noticed I was off a little bit on my decimal here, so I knew I must have rounded wrong a little bit. Okay? So always check yourself before you wreck yourself. All right, next page. And if I ever go too fast or anything, this video is up on Edline too. So if you need to rewatch this video at home, you are more than welcome to. I will upload it to YouTube and I'll send you guys the link. All right, excuse me. On this next one, let's do this problem here. They didn't really give you any directions on this. However, since what we're trying to find today is our missing angles, we're going to find both these missing angles, angle B and angle C, since we don't know them. So I'm going to go ahead and do angle B first. So from angle B as my reference, this would be my opposite side. Hypotenuse is always across from your 90-degree angle, and this is my adjacent side. So for angle B, we'll work on angle B on this side and angle C on this side. So for angle B, we know, we got to look and see, well, what two sides do we know? We know the opposite side is 5 and the hypotenuse side is 7. So we need, from our SOHCAHTOA, we need to know which one, which function are we going to use, which trig function. We know opposite and hypotenuse sides, so I'm going to use opposite hypotenuse side, the sine one. So I'm going to set it up as sine of B. Oop, my pen just freaked out. You know how it is. Sine of B equals the opposite over hypotenuse, so that's going to be 5 over 7. So there it's set up. I just need to solve it now. I need to get that B by itself. Oops, go away. So to get B by itself, I need to do the opposite of sine. So I'm going to do sine inverse of both sides. and then sine inverse to the other side. Since I'm kind of low on space there, I'm going to continue it down here. So sine inverse of 5/7 is the other side of the equal sign. All right, so this sine inverse cancels out this sign, so I'm left with b equals the sine inverse of 5/7. So b equals, when I plug into my calculator, sine inverse of 5/7, I get I'm sorry, I was just thinking. Sorry, sine inverse, let me plug it in. I didn't write it in my notes very well. 5 divided by 7 gives me 45.6 when I round to the nearest tenth. So 45.6 degrees. All right. And then on C, now let's pretend we didn't know what B is. In a minute, I'll tell you how we can find C easier without having to do trig if we already know what B is. But since we're pretending we don't know what C is, let me change colors here. Okay, C, my opposite side from C is this side. My hypotenuse, always in the same spot. And my adjacent then is this side. So in this case, I know the adjacent side and the hypotenuse side. So what I'm going to do is use cosine, because that's the one that has the adjacent and the hypotenuse. So cosine of C equals adjacent over hypotenuse, so that's 5/7. And now I've got it set up. Now I just got to get C by itself. So since we're working with cosine and I need to get rid of that cosine, I want to get C by itself, I do the cosine inverse of both sides. I know this is a little bit of writing. I'm sorry about that. Cosine inverse of 5/7. And if you run out of room on your paper, you're welcome to use a blank sheet to finish up the notes. All right, so the cosine inverse got rid of the cosine, so I'm left with C. And then cosine is equal to the cosine inverse of 5/7. And like I said, on my notes that's already uploaded on Inline, it's much better handwriting. So if you're having trouble reading what I wrote, check that out. When I type that into the calculator, second button, then the cosine button, and then 5 divided by 7. So we get 44.4. So C equals 44.4 degrees. Now, way to check myself, make sure 90 plus what we got for B, 45.6, plus 44.4 equals 180. So let me plug in my calculator and check. 90 plus 45.6 plus 44.4, boom, 180 exactly. If you do not get 180 exactly, then you've messed up somewhere. It could be in your rounding. Now, what I was telling you earlier is we found B using the trig function sine. So once I find one of those angles, then that means I've got a 90-degree angle, plus I know that B is 45.6 because I solved it using trig. So to find this third angle, I could actually just go ahead and add 45.6, sorry, my 6 is funky, and 90, add those up, and we get 135.6, and then subtract that from 180. Remember how all three angles add up to be 180, so we can do this. So 135.6, when I do that and I subtract, I get 44.4, and that tells me my other missing angle. All right, so if you're ever taking the test and they tell you to find both angles, use your trig function to find the one, and then do it the quick way over here to find your second one, because you know how you always have to rush to get those tests done. All right, let's do another example, because we love them. All right, on this one, this is a unique situation where we know all three sides. So technically, I can use any of them. I can use sine, cosine, or tangent, since I know all three sides. On the other one, we only knew two of the sides, and that's why we had to pick the exact one that we could use to find those angles. On this one, since we know all three sides, I could set it up 3 different ways, solve it all 3 ways, and I'll get the same answer for all 3 ways. So what I'm going to do is I'm going to show you how I'm going to set it, how we could set it up for all 3 ways. So if I am trying to solve angle A first, and it doesn't matter which one you solve first. You could solve for C first. It's up to you. I'm doing A. So this would be my opposite side. Hypotenuse is the one with the 10, and then my adjacent side's over here. All right, so if I wanted to use sine, let's put A over here because that's what we're finding. If I wanted to use sine of A, because that's the one we're finding, you always got to put your angle in the parentheses there. Sine would be opposite over hypotenuse, so that would be 8 over 10. If I had wanted to use tangent, it would be opposite over adjacent, so that would be 8 over 6. And then if I wanted to use cosine to find angle A, it would be adjacent over hypotenuse, so that's 6 over 10. So all three of these answers, if I do the sine inverse of 8 over 10, let's see what we get. I get 53.1. So taking the sine inverse of both sides, we get angle A equals 53.1. And I'm just going to kind of write right here, A equals sine inverse of 8 over 10. When I plug that in the calculator, I get 53.1. So let's do it with tangent inverse. So if A equals tangent inverse, because this is just me not writing that step of tangent inverse on both sides. So A equals tangent inverse of 8 over 6, and you are welcome to skip that step when you're writing your work. That's fine. A equals tangent inverse. So I hit the second button, then the tangent button, and then 8 divided by 6, and I get 53.1. Let me guess what we're going to get for the cosine inverse. A equals cosine inverse of 6 over 10. Second button, cosine button, 6 divided by 10. And I get 53.1. So this only works, you can only set it up all three ways if you know all three sides. Otherwise, you have to use the one that involves the two sides that you know in reference to that angle. So this is just a unique case where we know all three sides. All right, so since angle A is 53.1, sorry, that's a 3, I can find angle C just by adding 90 and 53.1, and I get 143.1, and then taking 180 minus the 53.1, we get 9 here, that becomes 9, so that's 6, that becomes 7, so that's 2. So we get, excuse me, 100, my bad, yeah, no, not 100, 26.9. So for angle C, we get 26.9. Now you can check yourself by doing it over here. And it's not a bad idea if you have extra time at the end of a test, take the time, double check yourself, because God forbid if you made a mistake over here somewhere, granted we checked ourselves 3 times, but if you just set up one of these, if you made a mistake somewhere and you got that angle wrong, then you're going to get this angle wrong too when you do this. So I would set it up as one of those 3 and solve for C. But since we set it up 3 times, I know we're good. All right, I'm going to skip a couple more examples. That way the video doesn't get too long. You're welcome to do some practice problems, use these as practice problems on your own. I do have the notes up there on Edline where I've worked these problems out, and you can check yourself. Let's do a couple of these together. So this is on a different page in your notes. It says, determine if you are calculating a missing side or a missing angle. Be sure to set up the correct trigonometry ratio, then determine the missing value. So this theta, this little Greek symbol that I told you about here, that's like a variable for an angle. So what they're telling us is we need to find this angle. And since it's in this A corner, that's the same thing as saying angle A. So that's the angle we're going to find. So we're hunting for an angle on this one. Excuse me. So if that's my reference angle, that's the angle I'm trying to find, then that means this side is my opposite side. across from the 90-degree angle. Oops, sorry. Let's just scribble that. This is my hypotenuse side. I was thinking hypotenuse, but my brain wrote A. And then, of course, this is my adjacent side. All right, so to find that one, that's just like what we're doing on this lesson today. We're hunting for that angle. So we're going to do, let's see, check out the two sides that we know. We know our adjacent side is 12 and our hypotenuse side is 13. So that means, go ahead and write on your paper. Make sure it's on your paper every time you do work any problems. You're SOHCAHTOA. So you can see your formulas there. Just memorize that. That's such an easy thing to memorize. And just to write at the top of your paper. So since we are working with adjacent and hypotenuse, that means we're going to be doing cosine. So cosine of angle A, because that's what we're trying to find, is equal to adjacent over hypotenuse, so that's 12 over 13. So now I just got to get A by itself. Well, to get A by itself, I got to get rid of the cosine. So we got to do the opposite of cosine, so cosine inverse. Whatever you do to one side, you got to do to the other. Oops, sorry, no, not inverse there. So A is equal to cosine inverse of 12 over 13. All right, so the cosine inverse cancels out my cosine, so I'm left with A equals cosine inverse of 12 over 13. And like I said, if you don't want to write out this whole step and you know how you get from here to here, you are welcome to skip that long step. So cosine of A equals 12 over 13, which means A equals the cosine inverse of 12 over 13. All right, so from there, I just type it into my calculator, hit the second button, the cosine button, and then 12 divided by 13. And we get A is equal to 22.6 degrees, since we're talking about an angle. All right, that's all we had to find. That's the only one that gave us a variable before, so that's what we're looking for on that one. I'm going to skip that middle one because it's another angle one. I want to come over here to this third one. It says they gave us this angle. When they give you the angle like that, they tell you it's 32 degrees, that's your reference angle. What they did do is they put a variable over here for this side. So that's the side we're trying to find. We're trying to find x. So we're finding a side. I'm going to erase that little arrow so that doesn't look weird to anybody and confuse anybody. All right. Go away. All right, so since we're trying to find x, before we start finding it, since this is my reference angle, I need to go ahead and label that this is my opposite side then, this is my hypotenuse, and this is my adjacent side. Fix that H. All right, so based on that, this is like what we did last class when I was here with you. So I need to figure out what that missing side is. The way I set this up is I look at the side that I'm trying to find, which happens to be my opposite side, and the side that I know, that 13, is my adjacent side. So I need to use the one that's going to use opposite and adjacent. So opposite and adjacent is TOA. So we're going to be using tangent. Tangent of 32 degrees, I'm not going to write A because we know this angle, is equal to x opposite over adjacent, so x over 13. So this is just like our warm-up today, and this is just like our homework that we did last night, or 2 nights ago. So tangent of 32 equals x over 13. Now, since I'm trying to solve for x, I need to get x by itself. So to get rid of that 13, I multiply both sides by 13. Whatever you do to one side, you got to do to the other. So on this side, we've got 13 tangent 32 degrees. Sorry, my pen's skipping on me. Is equal to x, because my 13s have canceled out. So x equals 13 tangent 32. This we just plug into the calculator. And remember, it's not tangent inverse this time, because we're finding a side. Tangent inverse is only when we're trying to find our angle. So when we're finding a side, it's just like last night's homework. So 13 tangent 32 gives me 8.1. So that x side equals, oops, sorry, my pen moved around, equals 8, I'm losing my mind, 8.1. Let me erase that other equal sign, it's gonna bug me. So bear with me, this is the first video I've ever made. Alright, so our answer is x equals 8.1. Now if they had said centimeter, like they had told me that this was 13 centimeters, then I would attach centimeters to this also. Now with angles, we know it's always degrees. Alright, so there's a couple of last practice problems to do with me. I did those with you guys. You are welcome to do those other practice problems on your own and with your own free time, just to get a little extra practice. Like I said, when I uploaded the notes onto Edline, I'm doing that. That's going to be separate from this video on Edline. It has all that filled in for you, so you can check yourself. So today, I had a closure for my other class, but since I'm not there, I'm going to skip a closure for you guys today. So all you're going to do is the homework assignment. Now remember, like I said, if you do not have a calculator at home, like the ones we have here at school, then you set up your problem, solve it to the point where you would put it into the calculator, and then as soon as you get to class the next time, before you do your before you do your warm-up, take a few minutes, calculate your answers, and then put those on there for you, and then do your warm-up. All right, so don't forget, next class is our review day. After that is our test day. So when I see you guys on Friday, that's when we take our test. We'll answer any questions that you have. When on your review day on Wednesday, I've attached a key to it so that with all my steps that I show how to work everything. So try them on your own, then check and see if you got the same answer as me. If you did not get the same answer as me, then check my work. See where you might have made your mistake. Okay? And always show your work on everything you do, guys. All right. I will talk to you guys when I come back on Friday, and I hope you all have a wonderful week. Again, be on your best behavior. Make good choices. See you Friday.